There are 5 ways to prove that lines are parallel. The first 3 ways, these ones right here, are by far the most popular way. Alright. The other 2 are less popular. Okay? The first 3 are the exact converse statements of what we just said in section 3.2. So I just told you guys, if 2 lines are parallel, then alternate interior angles are congruent. So what would be the converse of that statement? If 2 lines are parallel, then alternate interior angles are congruent. What's the converse? Yes?
If alternate angles are congruent, then the 2 lines are parallel.
There you go. That's one of the ways that we can show lines are parallel. Alright? We just take the converse of those 3 statements that we had in the previous section, and those are going to be our top 3. So here are the 5 ways to show that lines are parallel. The first way is you can show a pair of corresponding angles are congruent. If a pair of corresponding angles are congruent, then the lines must be parallel. Are you taking notes? Yeah? Okay, thank you. Okay, number 2. You can show that a pair of alternate interior angles are congruent. You can show a pair of alternate interior angles are congruent. Okay, so if a pair of alternate interior angles are congruent, then it must be the case that the 2 lines are parallel. Third way is you can show a pair of same side interior angles are supplementary on the top 3. Alright, and remember the top 3 ways are just the converse statements to every statement we made in section 3.2. Alright, and we're going to practice with this right now. You guys on board?
Yep.
Okay. Here we go. Okay, so here we go. I have this picture here. What do we know about this picture so far? Do we know that L and M are parallel? No, we're not. Let's say, for example, that we would like to prove that L and M are parallel. That's what we want to do. Okay, we want to prove that L and M are parallel. Now remember, there's 5 ways to prove that L and M could be parallel. Looking at those top 3 ways, which of the ways is represented here? What do you think? Yes?
Show a pair of corresponding angles that are congruent.
Yes, show a pair of corresponding angles. Do you guys agree that angle 1 and angle 2 are corresponding? Yeah. They are both top left, right? Now, if I want to use corresponding angles to show that 2 lines are parallel, I have to show what?
That they're the same.
That they are congruent. There we go. So, here's what I would say. I would say this. If angle 1 is congruent to angle 2, then, what can we say?
Angle 2 is congruent to angle 1.
L is parallel to M.
Got it.
That was the goal, right? To prove that the 2 lines are parallel. Okay. So if corresponding it, so the shorthand would be this, right? If.
How did we just like show that they're?
I'm just asking how we would do it.
But do we ever have to do that?
Yes. Yes, we do. I'm asking you how. I'm asking you basically for the plan of the proof, right? What your plan is going to be. If you can show that 1 and 2 are congruent, then that guarantees L and M are parallel. This is one of the ways that we could do it. And how many ways are there total? 5, and this is one of the top 3, right? So if corresponding angles are congruent, then we could say what? The lines are parallel. And that would be the shorthand way we do it in the proof. Here, ladies and gentlemen, same idea. Here's a picture. Okay, here's a picture. And the proof is going to ask you to prove that L and M are parallel, which is why I don't have little triangles on my picture right now. This is an awesome question, right? Okay, so how are angle 1 and angle 2, how are those related? Juliana, what do you see? Those are alternate interior angles, right? They're on the other side of the transversal, and they're on the inside of L and M. So what would I need to show about those alternate interior angles is true to then be able to say L is parallel to M? Yeah, what do you think, Alex?
Definition of the
No,
alternate.
you're close. I have to say something about the angles itself. Yes. There you go. If the measure of angle 1 is congruent to the measure of angle 2, then what can we say?
Then
L is parallel to M. Good. So this is another theorem that we have, right? This is the alternate interior angles theorem, the converse of that. So these angles 1 and 2 are alternate interior angles. So what we'd say in the proof is this: if there you go, alternate interior angles are what? If they're congruent, then what? There you go. Then capital P. That's what we would put in our proof. If alternate interior angles are...
just have to say like what they are.
All right, here's my next picture. I've been given this picture here. Okay, I'm trying to prove that L and M are parallel. What's the relationship between angle 1 and angle 2? What types are those? They're same side interior. So if, what can you say? If the measure of angle 1, no, plus the measure of angle 2 equals 180, then what can we say? Then capital P. Exactly. Then capital P. These are same side interior angles. Right there. Same side interior angles. And we know that if same side interior angles add up to 180, it must be true that L and M are parallel. That's the third way that we're going to do this, okay?